All right, so for your assignment last night, I asked you to do the exploration on page 244. And so what we are trying to do is we're given these derivatives and we are asked pretty much to find what function would have that derivative. And so you could have got a lot of different things. So for for a derivative of 2x, you may have said that f of x was x squared. Someone else might have said that f of x was x squared minus 7. Or someone could have said f of x was x squared plus 15. Those are all true. All of those functions have a derivative of 2x. Okay? And then same thing for a function that would have a derivative of x. That could be, you could have just said 1/2 x squared, or you could have said 1/2 x squared plus pi. There's an infinite number of functions we could create, right? And then to get a derivative of x squared, you might have just said 1/3 x cubed, or you could have 1/3 x cubed minus 100. I don't know. All right, and then to get a derivative of 1 over x, maybe you guys said it was derivative of 1 over x squared, you might have just said 1 over x. That's not quite right. It would actually be negative 1 over x. Or you might have just added some kind of power. There's some kind of constant to that as well. All right, and then to get a derivative of 1 over x cubed, you would do negative 1 over 2x squared, and then I'm just going to put plus 17. That would have a derivative of 1 over x cubed. Okay, and then for cosine of x, the function that has the derivative that is cosine is the sine function. And we could do sine of x plus 1. In general, what we end up doing is plus c for any constant that you want to think of. All right. So what we're going to start doing today is finding antiderivatives or indefinite integrals. And so some important ideas. If we're given a function f of x, the most general antiderivative is given by the integral from the integral that it's an indefinite integral if we don't have an upper and lower limit. So the integral of f of x dx is equal to, we'll do a capital F of x plus c, where f prime of x is equal to f of x. So if we take the derivative of that capital F of x, we get the integrand. All right, so we have a lot of antiderivative rules here, and there's even more that we're going to learn. But if we have the antiderivative or the indefinite integral of k dx, just a constant dx, that's just what you end up doing is just basically adding an x on or multiplying by an x. Because if you're trying to figure out what has a derivative of 2, that's going to be 2x would have a derivative of 2. Okay, for the power rule for antiderivatives, what you end up doing is adding 1 to the power and then dividing by that new power. Now, I forgot something that was super important on that first one. Let's not ever forget the plus c. All right, so the power rule, you add 1 to the power and then divide by the new power. Now, this only works for powers that are not -1. When the power is -1, like this next one, 1 over x is the same as x to the -1, we don't use the power rule, because if we did, we would end up dividing by 0. So if you think about what function has a derivative of 1 over x. If you guys remember, that's the natural log function. So the antiderivative of 1 over x is the natural log of the absolute value of x. So we do have to include the absolute value. All right. And then the antiderivative of e to the x dx is just e to the x, but then don't forget your plus c. All right. And then if we want the antiderivative of sine of x dx, think about what we can take the derivative of, and you end up with sine. Now, that's actually going to be negative cosine of x, because the derivative of cosine is the negative sine. But if I want to end up with just sine, I have to do the derivative of negative cosine to get sine. All right, and we already did this one on the front, or on the exploration. It's going to be sine of x plus c. Okay, then we want the antiderivative of secant squared of x. So think about what function has a derivative that's secant squared, and that function is tangent. All right, this one should be negative cotangent plus c. All right, and then we start thinking what function has a derivative that's secant x tangent of x, and that function is secant of x. And then since we're doing the antiderivative, we have to add a constant. And then this one should be negative cosecant of x plus c. So if you notice, all of the antiderivatives whose answer has a co, it's a negative co. So try to remember that. If you are finding the antiderivative and you end up having to put co something, then it's going to be a negative. All right, so on our example 1, we have several. We're going to find the indefinite integral. So whenever we're doing the indefinite integral of just a constant, whatever the variable is, which in this case is x, it's just going to be that constant times that variable and then plus c. All right, for b, I'm going to do the power rule for integrals, which means I'm going to add 1 to the power and then divide by my new power. All right, and if it's the integral of a constant, it's just that constant times x and then plus c. Right, and then you can just find the derivative in your head real quick just to make sure that's right. Now, if I did the derivative of this answer, it would give me back the integrand. All right. Now, one thing we can do if we are multiplying by a constant, we can bring that constant in front of the integral. And then the derivative, the antiderivative of e to the x is e to the x plus c. Okay, now we do not have a quotient rule for finding the integral. So what we would want to do in this case is go ahead and divide each of those by x squared. Okay. Then you would want to use the power property for finding the integral, which means we add 1 to the power and divide by our new power. Okay, when that power is negative, it's the same thing. We still add 1 to the power. When I add 1 to negative 2, I get negative 1 and divide by my new power. Okay, and then I'll just kind of clean this up. So that's x squared over 2. And then we'll have a positive divided by negative is a negative. And then I would leave the 5 in the numerator and x to the first, or just x in the denominator. Okay. Right. And then this is just a rule from above. So if I want want to find the integral of cosecant squared of x dx. This is going to be negative cotangent of x plus c. And then for this one, I could pull that 2 in the front, where I can just know that the 2 is going to be there. I know that my answer is going to be a co, so it's going to be negative 2 cosecant of x plus c. All right, and then for this last one, we're going to find the function whose derivative is given by f prime of x equals 4x cubed minus 2x squared plus 7x plus 1, and passes through the point 3, 8. So we're going to start off and just do the antiderivative. So that means I'm going to add 1 to the power, divide by my new power. Add 1 to the power, divide by my new power. Just keep doing that. And plus c at the end. Okay, and then I'll clean it up a little bit. There's not a lot to do, just basically divide 4 by 4. Oops. Okay, and then we're going to use this idea that when I put 3 in, I'm going to get 8. All right, so I know that f of 3 should equal 8. So what I would do is I would go ahead and put 3 in for all of those x's. Sorry, it's taking a minute. All right, so I'm going to have x to the 4th minus 2/3 x to the 3rd. Oops. Oh, sorry. Oh my gosh. Okay, so I get 97.5. Sorry, I hope you guys fast forwarded through that. And then I still have that plus c though. So it would be 97.5 plus c. And then to figure out what c is, we would just subtract. So c is negative 89.5. So the function I'm looking for would have that in place of c. So it should be f of x equals all that stuff. And then minus 89.5. All right, so what I want you guys to do for your assignment is out of the book. It's on page 251. I want you to do 12 through 32 even. And then on page 334, I want you to do 1 and 2.